So we know that 2 to the power of 3 is equal to 8. But what if we wanted to write this as a logarithm? Well, the way we would do it is we would say that log to the base 2 of 8 is equal to 3. So let's look at the comparison between these two. So our bases, so our base here being 2, and this number here is what we call our base. So I said log to the base 2, so this base stays the same. But what the log's kind of saying is it's saying, okay, what do we need to put 2 to the power of to get this number in here? And the answer, so log to the base 2 of 8, the answer of that would be 3. We need to put 2 to the power of 3 to get 8. And you can kind of see the comparison between the indice form on the left here and the log form on the right. We'll do a couple more just so that you can kind of get the hang of how we convert between the two. So what if we had, so we know that 5 squared is equal to 25. If we were going to write that as a log, we would say log to the base 5 of 25 is equal to 2, because I need to raise 5 to the power of 2 to get 25. We might do just one more. So 4 to the power of 3 is 64. So I could write that as a log. I would say log to the base 4 of 64 would be 3. I need to put the number 4 to the power of 3 to get 64. So the general kind of equation that we've got is that if we've got a to the power of x equals b, if I want to convert that into a logarithmic equation, I just say that log to the base a of b is equal to x. So this is kind of the golden rule that you can go by, and you can check that that works for each of 1, 2, and 3 examples that we just did previously. So hopefully that kind of makes some sense. It'll take some getting used to, but hopefully you can see the relationship between how a logarithmic equation can be converted straight back into an exponential equation and vice versa. Let's take a look at a few more examples. So first of all, can we solve what log to the base 10 of 1,000 is equal to? So that is equal to x, and we want to find what x is. Okay, well, if I convert that back to the indice form, I'd be saying that 10 to the power of x is equal to 1,000. Now remember, when we're trying to solve these indices with our unknown in the power, we need to get our bases the same. So I can say that 1,000, well, that's just 10 to the power of 3. So 10 to the power of x is 10 to the power of 3. So now, because I've got the same base, I can compare my indexes here. So x is equal to 3 in this case. So we can say that log to the base 10 of 1,000 is equal to 3. If we take a look at another one, let's try and work out what log to the base 16 of 4 is equal to. So that's equal to x, and we want to work out what x is. Well, if we convert back to the indice form, so 16 to the power of x is 4. Now I can write 16 as 4 squared to the power of x now is equal to, well, this is just 4 to the power of 1. So notice how I've got them so that we've got the same base. Well, if I use my indice law where I just multiply these two numbers together, so 4 to the power of 2x is to be 4 to the power of 1. So I see here, comparing my indexes, that 2x needs to be 1, so x is 0.5 in this case. So log to the base 16 of 4 is just 0.5. We'll do another one. So thirdly, let's work out what log to the base 8 of 0.25 is. So we want to work out what that is. So solve for x here. Well, again, I'll convert it back to my indice form. So we want to work out, okay, well, 8 to the power of x needs to be 0.25. Okay, well, I can write 8 as 2 to the power of 3. And well, my 0.25 is just a quarter, which is just 1 over 2 squared. Okay, so now I've kind of got similar bases happening here. So I've got 2 to the power of 3x, and instead of 1 over 2 squared, let's write that as 2 to the minus 2. So now comparing my indexes, 3x needs to be minus 2, so x would be negative 2/3. So the answer to this log to the base 8 of 0.25 would just be negative 2 over 3. If we do another one, so question 4 now. Now we're going to try and work out what log to the base e of 1 over e squared is. And before we go any further with this, I just want to make the point that if we've got log to the base e, sometimes that's written as just the natural log, so ln. So log to the base e of something is just the same as ln of 1 on e squared. And you probably see this button on your calculator somewhere. So ln is just another way of writing log to the base e, and it stands for the natural log. So if we're going to try and solve this problem, so when this is equal to x, again, we're just trying to work out when e to the power of x is equal to 1 on e squared. So let's write that 1 on e squared as e to the minus 2. So in this case, x would be minus 2. So your answer to this equation here, log to the base e of 1 on e squared, or the ln, the natural log of 1 on e squared, is just negative 2. Let's do another one. So question 5 now, I think we're up to. Let's work out what log to the base 15 of 1 is. So we want to work out what log to the base 15 of 1 is. So if we solve that for x, then we're saying that 15 to the power of x is 1. So what do we need to put any number to the power of to get 1? Well, anything to the power of 0 is 1. So x here is just 0. In fact, log to the base a of 1 is always going to be 0, no matter what this base is, because it doesn't matter what number is here, whether it's 15, 100, 2, it doesn't matter. When I put it to the power of 0, anything to the power of 0 is 1. If we look at another question, so question 6 now, we might want to solve when log to the base 10 of 0. What is that equal to? Well, if we set up our indice form, we say that 10 to the power of x is equal to 0. And well, I can't put 10 to the power of anything to get 0. That's not possible. So here we actually have no solution to this equation. And again, it doesn't matter what my base is, log to the base a of 0, there is no solution there. So if you try to put log to any base of 0 into your calculator, you're going to end up with no solution. In fact, a point that I do want to make is that this log to the base 10, if we're ever looking at log with a base of 10, sometimes that would just be written without the 10. So that would just be log of 0 in that particular case. So it's the only one where we don't worry about the base and we can just write log. So that's just the kind of general notation for that. Similar to how you've got log to the base e being the natural log. If we do another example, so what number are we up to now? Number 7. So I think these ones start to get a little bit trickier. We want to work out when log to the base x of 64 is equal to 6. Well, again, if I convert that into indice form, we're trying to look at when x to the power of 6 is equal to 64. In fact, to isolate this x term, what if I raised both sides to the power of a sixth? Well, then 6 times a sixth is just 1, so I just leave my x here. And 64 to the power of 1/6, I'm looking for the 6th root of 64. And you can take some time to think about it, but the 6th root of 64 is just going to be 2. So in this particular case, x over here would be equal to 2. If we do one more, so we'll do question 8, log to the base x of 4 root 2 now needs to be equal to a half. So they're starting to get a little bit trickier. If I convert that into my indice form, we're saying that x to the power of a half is to be equal to 4 times the square root of 2. So if I raise both sides to the power of 2, then this part here is just going to become 1 when I multiply those together using my indice rule. So I end up with x. And 4 times root 2 squared, so I end up with 4 times 4 is 16, and then a root 2 times a root 2 just gives me 2. So 16 2's are 32, so x would be equal to 32 in this case. Finally, I have one very last example that I just want to have a look at. So can we work out when e to the power of x is equal to 10? And if you go back right to the very start, see if you can get yourself comfortable converting back to the logarithmic equation here, which just says log to the base e of 10 would be equal to x. So now we've actually worked out that x is equal to log to the base e of 10. And another way to write that, remember, is just ln of 10. Okay, so the natural log of 10 is equal to x. And if you pop this into a calculator, you would end up that x is actually 2.30. So there's no way that you would be able to kind of work that out without the use of logarithms. You could do trial and error, but you'd be there a while to get pretty close to this number. So that's the power of logarithms, and that's why they're really important.